I just wanted to review a little bit for the test coming up and finish up that review problem. So here we go. Okay, so there was no class on Friday. The exam's coming up on Monday. The online section of the test is from 6 to 6:50. The in-class section is from 1 to 1:50. Remember to bring a photo ID and a non-programmable calculator. All right, here's some of the topics that could be on the exam. This is the stuff that we covered. So we started off with 2D force components and resultants, just using right-angled trig to break vectors into x and y components, adding them up to get resultants, and then the magnitude of the resultant is sum of fx squared plus sum of fy squared, and then take a square root of that, and then the angle would be arctan sum of fy over sum of fx. Okay, then we went through finding unit vectors for 3D forces. That can either be done by taking the cosine of the three angles that the vector makes with the x, y, and z axes. That could also be done using double projections on some of these angles. And it can also be done by finding a position vector from one point to another, and then dividing through by the magnitude of the vector to find the unit position vector. Once you have the unit position vector, you multiply it by the magnitude of the force, and that will get you a force vector. Okay, we also covered dot products, which gets you the projection of a force onto a line. Dot product is a scalar. You just multiply the like components together of the two vectors and add up the products. Once you have this projection of a force onto a line, which if it pulls on the line is tension, or if it pushes in on the line is compression, what that is one of the two components of the total force. So the total force is made up of the component parallel, or the component that is a projection of the force onto the line, which is either tension or compression, and the shear. So you can use this vector equation here, F compression or tension plus F shear is F total. So if you've got one of these things, you can find the other by taking the total minus the one you've got. Okay, we did 2D particle equilibrium. Sum of fx is 0, sum of fy is 0. And we covered these three special types of forces: cables, pulleys, and springs. So you use right-angled trig in these situations to get the x and y components, add them up, set them equal to 0. Okay, 3D particle equilibrium, you've got three different equilibrium equations for x, y, and z. Probably best to follow more of a vector approach on that. So make each force into a vector expression, put the vectors in columns, and add up the rows and set them equal to 0. The rows are then x, y, and z. Set them equal to 0 and add them up and solve for your unknowns. Okay, 2D moments. Moment is force times distance. Be sure that your distance is perpendicular to the force. It's very common to break up both the forces and the distances into x and y components. So an x force is perpendicular to a y component of distance. A y force is perpendicular to an x component of distance. You can then multiply the appropriate components together and add them up to get the total moment. In 3D, a moment is a cross product, r crossed with f. R is any position vector from O, which was the point you're taking moments about, to the force. You can then find the magnitude of a moment about an axis by taking the moment vector and dotting it with the unit vector for the axis. Okay, we also had this vocabulary. So you should know these words and be able to understand them if they're in problems. Vector versus a scalar. A resultant, a vector has direction. A scalar is just a quantity, a magnitude, basically. A resultant is the sum of two vectors. Projection, projection along or parallel to, tension and compression are all different versions of the same thing. They're found in 3D using a dot product. And so what you find with that dot product is the magnitude of a force that is directed along a certain line or projected onto that line, you might say. That could also be called a component parallel to. Okay, you also have a projection perpendicular to the line, which would be the shear. That could be the component perpendicular to as well. Component is part of a total vector that is directed in some particular direction. Cartesian vector is an XYZ vector. Angle with the blank axis would be either alpha, beta, or gamma. Alpha for the x-axis, beta for the y-axis, gamma for the z-axis. Equilibrium is when the sum of forces equals 0. Moment about a point is like the sum of moments about O. Moment about an axis is the moment of a force about a given axis. All right, now, 3 things that will for sure be on this test is, first thing, finding a force vector. Okay, certainly I'll have you use position vectors at some point to do that. Okay, and I might have you use angles as well, but I'll certainly have you find a force vector using position vectors. I'll have you do a dot product to find a projection and a cross product to find a moment down here. There we go. All right, so those are 3 things that will for sure be on this test. Using position vectors to get a force vector, using a dot product to find a projection, and using a cross product to find a 3D moment. Here's some examples from some old tests. Okay, let's find on this one what you do would be to use the 3 angles to find the force. Now keep in mind that these problems are available online. They're in the test review section of Moodle, so you can go get them there. So here's the test review downloads. There's the statics test 1 review sheet. Here are the 2 sets of problems, or 2 pages of problems that I put in there. Okay, so there's the first problem. The second problem is a double projection. So there's a bit of practice, a practice problem on that, taking F2 and making it into a Cartesian vector, an XYZ vector. The next one here, we want to find this force vector that goes from A to B. You've got the magnitude of the force, and you've got the position of A and the position of B. So you would go through that process of finding the force vector from A to B. Okay, the next one here, we've got 2 points, A and C. I want you to find the position vector from A to C and the unit position vector from A to C, and then the position vector from C to A, and the unit position vector from C to A. Now, in this particular test, I had people find those vectors on the first 4 problems, and then use the vectors on the next 2 problems. So the idea was I didn't want you to have to keep finding 3-dimensional vectors all the time. It's fairly time consuming. So I had you find a bunch of vectors first and then use them in the next part of the test. So the first thing I want you to do with those vectors is to find the compression in AC caused by FAB. That would be a dot product. Okay, and you should get about 3398 for that. Then once again, use the vectors that were found in problems 1 through 4. Find the moment of FAB about point C. That would be a cross product. So here's one example of how I'm trying to save you some time by having you find a set of vectors first and then use them, so you're not constantly finding vectors. Okay. Here's another problem finding the resultant of F1 and FAB. So you just find each of the vectors, add them together, and get the total. And then finally we have a two-dimensional equilibrium problem, where I want you to find the force in AB and the force in BC. So those are just some problems off of old tests. You should certainly study more than just those. I mean, you know, that's just some examples of what the test might look like with some of the problems. So just so you have an idea of what to expect. Now, I can do this in a different way too. The example that I just showed you there was, on this one was on problems 1 through 4, you found the vectors, and then on problems 5 and 6, you used them. Now, another approach I've taken on this in the past is found right here under the test review downloads, let's see, Statics Exam 1 vector example. Okay. And that's right here. Now what I've got here is on the back page, I might just show you a number of vectors. Okay, and so I've got points A and B and C. I've got all these different vectors listed. So our A, B, and C. I've got a position vector shown right there. And then I've also got a unit vector shown right there for that particular vector. And then I've got them for RAB, RAC, and RBC, it looks like. And I show you all the position vectors and all the unit vectors. And then I might ask you some questions using these vectors. And I would say, you know, use anything you want from this table that you would like to use to solve. So you could use, you know, a position vector if that's what's called for, a unit vector. You know, if you need a force vector, for instance, you probably have to use a unit vector and factor it up by the magnitude of the force, okay? So, you know, you could use these vectors that I've calculated for you in any way you'd like, is the idea. And you might have to turn like a unit vector into a force vector. You might have to turn a vector around so it goes the opposite direction, you know, whatever. I mean, but I would have this basic information here for you to use. That would be the idea. So that's another way I could put vectors on a test that would help you work through it more rapidly, okay? And so I just want to prepare you for what you might see on the test. That's why I'm going through this. All right, a couple other things. First thing is on this test to remember is, let's say, you know, you want to figure out all those steps, especially for the things that I mentioned that I will for sure test you about. You know, and there are 3D operations. They have a series of steps in them. So you should get those steps figured out, you know, before you come to the test so that you can just walk right through it when you have to do that, okay? Now, let's say it's a 5-step process and for some reason you're having some problems with step number 2. Just be aware of how I grade these tests. I break the solutions for the problems into steps, and I'll give you a certain number of points for each step. So if you hang up or have a problem with step number 2, you should just assume something for that and use it on steps 3, 4, and 5 to solve, okay? So even though you're hung up on something, still proceed through the problem so I can give you as much partial credit as I can, okay? So that's one thing you want to be thinking about. You know, it's up to you to show me what you're doing, so remember that too. You don't need to overkill it, but I need to be able to see what it is you're doing. You know, it's especially important if you make an error somewhere, which isn't uncommon on a test when you're in a hurry and under a bit of pressure there to make a numerical error or something. If I can track that through, it's not that big of a deal. I'll just take a point or two off for making some sort of little numerical mistake. But if I can't figure out where your numbers are coming from, that's a whole nother issue. I'll take more off in that situation. So just be sure that you're helping yourself and that you're showing me what you're doing as you're going through these solutions. Okay, the last thing I'd mention about the test is in the past, and you know, I could very well again put a little bit harder problem on there. It might be worth 6 or 8 points. So it might be a little challenging, but it's not worth a huge number of points out of my 100-point test. So just keep your eye on what the value of the problems are. Don't spend 30 minutes on a 10-point question. That's just not worth it. So, just remember those things as you're working through the test. Now, the other thing that I'd like to do here would be to finish this problem up. This was that isn't it there, is it? Okay, it was this problem here. So it's sort of the homework downloads. It's the 3D review problem. And it has the date on there. I'm not sure what it is. I've also posted a solution for this. All right, so what I give you there is a 3D problem. We got a force pulling on a rod. The rod's connected to a wall at this point A here. And what I'd like you to do would be to find, I'll give you some values here for that rod. I give you the tensile strength, the compressive strength, and the shear strength. And I also give you the moment strength. And then I ask you to see if it will fail. Okay, so you just need to find a force vector and then test it for compression or tension, one or the other. And what you would do for that, of course, is a dot product. Test it for the shear using the approach we used in class. And then also test it for the moment using a cross product. See if this force here that goes from B to C will cause any forces on, or any forces or moments on this rod that would cause it to fail, i.e. to exceed any of these values. All right. So we went through a bit of that before. So what you need to do first is you need to get a position vector from B to C. Take the square root of some of the squares of the position vector, make it a unit vector from B to C, and scale it up by the 5200. That'll get you the force vector right here. Okay, now notice that that force vector is pulling B, or I don't know what the right word is there, pulling or pushing B towards A is what it's doing. So if you look at that component of that force vector, it looks like that if you were to make that into a component there. Okay, so what we have here is compression. The cable is taking B and pushing it in towards A, and that's compression. There is no tension in this problem, so the only strength you have to worry about on that is the compressive strength, because even though the material has a given tensile strength, there's no tension being applied to that rod. All you have on this one is compression. So you'd be looking at the compressive strength. Then what you would do next here is you would find a unit vector from B to A, okay, as shown there. So you're going to get the position vector, in this case from A to B, find its magnitude, divide through, and get a unit vector. You could either go A to B. It might make more sense to go from B to A because that's how the compression is directed, from B to A, okay? But you could use either one. If you use BA, you'll get a positive answer for your dot product. If you use AB, you'll get a negative answer. No big deal. Okay, then you take the dot product between the force vector and the unit vector from B to A. That will get you the magnitude of the compression of B being pushed towards A. And then if you have that compression and you have the total, you can take, using the theorem of Pythagoras, because these are all right angle components here, like so. What you've got there is you've got the compression, and then perpendicular to that is the shear, and then the shear and the compression added together as vectors gets you the total, okay? So you can take the total squared, the 5200 squared, minus the compression squared, take a square root, and you'll get the shear 4220. All right, and then the last thing here is to find the moment. Remember, you have the moment formula right on your formula sheet. I'd suggest looking at that formula sheet and finding where the formulas are and what they look like so that you'll know what they look like. Also be sure that whatever calculator you choose to use is non-programmable and that you've practiced with it before the test, okay? So we have the cross product formula, and then we have a cross product there. You can run the numbers on that, and when you run the cross product, you'll get the moment about A. So what we're doing there, we're taking the vector from A to B. So that's the vector that starts at A, where we're taking moments about, and is directed to B. So there it is right there. Well, I didn't draw that quite the way I'd like, but you get the idea. There's a little bit better version of it. So there's RAB. And then I cross it with the force BC. So it's R crossed with F in that order. Be sure again, it's from A to B for your R vector there. Do the cross product, you'll get the moment. Take the square root of some of the squares, and you'll get the magnitude of the moment, which is 19,343. Okay, so that's the basics of doing that problem. I also have the little bit down there at the bottom that asks what is the maximum force, or what I guess is the minimum force that would cause BC to fail. Fail means to have the applied forces exceed the allowable forces. So look at what force is required here in this wire from B to C. What force is required there that would overload the rod, put too high of a load on the rod, and the allowable loads for force and moment are given in the problem statement. Okay, so that's what I'd like you to do for that. This is all due on Wednesday with your homework. Okay. So there you go. That's a run through that.